Okay, here we're asked, a baseball player slides into second base with an initial velocity of 3.5 meters per second. If he slides for 1.25 meters, what is the coefficient of kinetic friction? Step 1, draw a free body diagram. So here's my baseball player. He is sliding into second base. So he's on Earth's surface, so there is a gravitational force. He's on Earth's surface, so there is a surface. Therefore, there's a normal force. I'm going to say that this field is horizontal, therefore normal or perpendicular to horizontal is vertical. And then there's on a surface and he's sliding across that surface, so he's moving, but there will be a force of kinetic friction opposite his direction of movement. Okay? Now, once he starts his slide, he's not pushing forward anymore, so there's no applied force moving him forward. It's just the friction slowing him down. Okay? So, step 2, write down our givens. Well, player slides into second base with an initial velocity of 3.5 meters per second. So his initial velocity is 3.5 meters per second. Okay? He slides for 1.25 meters. That's a distance. And he's going this way, that's the x direction. So I'll say the change in x, or the displacement, is 1 meter and 25 centimeters. Okay? What is the coefficient of kinetic friction? So we're trying to find the coefficient of kinetic friction. Now there's one other thing that I know up here. Okay? When he gets to second base, he's going to come to a stop. Okay? Because he wants to be stopped at second base, so he'll force himself to do so. So he's got the final velocity of 0 meters per second. So now what else do I know? Well, I know that he is accelerating. He's slowing down. So I know that Newton's second law is going to hold here. The net force is going to be equal to the mass times the acceleration. Now he's not slowing down vertically. He's only in the x direction when he's slowing down. In the y direction, he's sliding along the ground. He's not going up or down at all. So in the y direction, I also know that he's not going up or down at all. He's not accelerating up or down. So therefore, his net force in the y direction is 0. Once we write down these net forces, we want to look and add up all the forces, make a second equation. So the net force in the x direction, I need to add up all the forces in the x direction. Well, there's only one. And it is pointing to the left, so I'm going to make it negative. So the force of kinetic friction, that is our equation. Okay? In the y direction, I see more than one force. Okay? In the y direction, I see the gravitational force acting downwards, so I'm making that negative, plus the normal force acting upward, so that'll be positive. And I don't see any other forces or components going up and down, so we're done there. So the next thing I want to look at is what I'm trying to find. I'm trying to find the coefficient of kinetic friction. Well, what equation has that in it? Well, there's only one. The equation that has that in it is the force of kinetic friction is equal to the coefficient of kinetic friction multiplied by the normal force. Okay. So we need to know this force over here of kinetic friction. Well, a little lucky there, because the force of kinetic friction I can substitute in right here. So negative force of kinetic friction is equal to the mass times the acceleration. So I've got that equation. Okay. Then the normal force will be over in this one. Okay, so I can substitute the 0 in. And I can go ahead and figure out the gravitational force, which we don't know, but I do know that the gravitational force is equal to the mass times gravity. We made this negative, so I'm going to put negative mg in here, plus the normal force. And now I have some things, I don't have any numbers yet, but I'm going to go ahead and substitute these values in, okay? Now this one I can't quite substitute in yet because That's a positive force of kinetic friction. This is negative, so I need to divide everything by -1. So the force of kinetic friction is equal to negative ma. So over here, we go ahead and substitute that in, that portion. So negative mass times acceleration is equal to the coefficient of kinetic friction multiplied by, now I need to go over here, okay? Well, I need Fn. I didn't solve for it yet, so I'm going to move this to the other side by adding it. So the normal force is equal to the mass times the gravitational force. Place that over here. And now I'm ready to start solving. What you're going to notice is first, there's a mass on both sides. If I divide both sides by the mass, simply cancel that out. So negative acceleration is equal to the coefficient of kinetic friction times the gravity. I know this is 9.81 newtons per kilogram. I still don't know this acceleration. We need to go back to chapter 2 and look for some of those equations to find the acceleration. Okay, because we need to know the acceleration. So look through those equations. We find an equation that says the final velocity squared is equal to the initial velocity squared plus 2 times the acceleration times the change in displacement. The final velocity was 0, so we have 0 squared, equals the initial velocity is 3.5, so 3.5 squared, plus 2 times the acceleration times the change in displacement, which is 1.25. 0 squared is 0, 3.5 squared is 12 and 25 hundredths, plus 2 times the acceleration times 1.25. I'm going to move the 12 and 25 hundredths to the other side by subtracting it. So negative 12 and 25 hundredths is equal to, I'm going to also combine these right now. 2 times 1.25 is 2.5 times the acceleration. Divide both sides by 2.5. And I get my acceleration is equal to negative 4.9 meters per second squared. So up here, I have negative, put my acceleration in negative 4.9, is equal to the coefficient of kinetic friction times 9.81. Negative, negative cancels out, so I just have 4.9. Divide both sides by 9.81. And I get my coefficient of kinetic friction is 0.4994. If I want to round to the first decimal place, I would have to make that 5, so it would be 0.50.